Thank you, guys. It's really amazing to be here in this room with 500 or maybe 400, thanks to last night's activities, all of whom are crazy passionate about CLT. It's a phenomenal, just feels like I'm home. I haven't been to a conference where every single presentation I go to brings me something useful immediately. I'm writing it down, I'm figuring it out. Thank you all for all of your knowledge. I'm learning from all of you, and I hope I can contribute to that little piece of it here. You know, we've talked a lot on our house. You probably, I'm going to show two projects here. I talk almost every week on this house. People are so interested in this house and this project and really what we're doing in this room here. So if you've heard pieces of this presentation before, I apologize, but it's also a huge honor to be able to give it to this concentrated group at this moment in time. When I was 5 years old, my grandfather took me by the hand and we walked through this forest. There were little trees planted everywhere, Douglas fir, spruce, and pine trees. My grandfather told me that when I was an adult, all of these trees would be grown up and ready to harvest. He could see the forest of the future, and he was proud, very proud of what he had planted for his grandchildren. And 45 years later, my grandfather and grandchildren and his family remembered what he had told us, and we revisited the forest. We looked for the Douglas fir and the spruce and the pine trees, and we could not find very many of them. Instead, there were hundreds of beautiful, lacy, delicate hemlock trees, Washington State's state tree. But they weren't very big. They were crowded. They were crowded together, rather small, 6, 8, 10 inches, even after 45 years of growing. And we couldn't figure it out. So we talked to the foresters, and we talked to the ecologists, and we learned that an unmanaged forest is not a managed forest. And indeed, for 45 years, our forest had become an unmanaged forest, overtaken by many trees, even many small, quick-growing trees, crowding against one another all over the western part of the state of Washington. We also learned what many Europeans had known for a long time, that if managed properly, growing small diameter trees is a way to keep forests healthy, and trees healthy, and to keep a wood supply flowing, and to keep trees sequestering carbon. Lots of carbon. Carbon in the harvested small wood, carbon in the trees that would be replanted, carbon in the trees still growing. And so our family learned how to manage our forest, and we took down a lot of the small crowded trees, and we let the other Douglas fir trees and western white pine trees get light and air to grow bigger. And then we planted more and more Douglas fir, western white pine trees spaced so they could all get light and air. And now we have a managed forest for my grandfather's great children's future. We also learned that for 2 decades, the Europeans have been making this very strong wood panel called cross-laminated timber, and that it was made up of all the small pieces of all the small diameter trees, and they were all finger jointed together. And I looked at those large, awkward, strange panels and said, these are very beautiful things. I want to make a house out of this constructed wood. I want to use this wood. I want to use this kind of Northwest new wood. I want to live with this wood and explore this new material and experiment with it and build with it. The panels were exciting. Not only were they good at sequestering carbon, they were smart and high-tech, and they could have openings cut in them for light and utilities, and they could be assembled very fast together on a construction site with just a couple of guys and a construction crane. And even when they were put together, made into a building, they still sequestered carbon. And all of those trees that were replanted after the panels were harvested then from them, they were also sequestering carbon. And I learned that the panels could also replace other materials, including the structure and the gypsum wallboard, and you could leave the wood exposed on the interior just like that and replace other carbon-emitting materials. The edges of the panels could be mitered together to make very beautiful spaces to capture light and space in a very warm way. And all of this brought back memories of growing up in a small town in western Washington, where my family would visit my grandmother's cabin in the San Juan Islands, and how we would travel on the highway and on the ferry and on the little roads and down the gravel road, and finally open the door of the little cabin and be immersed in the woods and the smell and the light of a cabin very far away, and how the cabin was small and wooden and beautiful. And I thought, what about making a new kind of beach cabin? An urban beach cabin. One that would be very beautiful and sequester so much carbon at the same time. So we began. Our architectural firm, Atelier Jones, researched over 5 years, and we learned a lot about cross-laminated timber. I called around the country, and up to the far reaches of northern Quebec. I talked to Swiss lumbermen and Canadian businessmen. I taught a studio at the University of Washington, and with my 12 excellent students, we researched a lot about this CLT. And with my firm, Atelier Jones, we researched how to build with this new kind of wood and to make a new Northwest beach cabin in the city. We learned that America was far, far behind in making CLT panels, and that the closest panels at that time were from British Columbia, from Structurlam, and that they made CLT panels from FSC plant-certified wood. And when we visited Structurlam, we learned how they made the panels and how we learned how to coordinate with their CNC computer programs and their shop drawings so that when the panels would arrive on our site, they would fit together perfectly. So our contractor was not too worried about having to build, how to build with the new materials. And then I learned also that our family would have to buy the panels separately because the banks would not lend us any money for this kind of new construction. But finally, in 2014, our family ordered the panels, and 6 months later, they arrived on site for the contractor to assemble in just 12 crane days. Now the house is finished, and all the carbon is still safe in the panels and safe in the growing trees, carbon copies. Our 1,500 square foot house is certified Built Green 5-star. It has beautiful triple glazed Euroclimb windows and doors and uses passive house techniques to make R35 walls and an R49 roof. It's projected to use 38% less energy than already our stringent Washington state energy codes use. And there are rooftop planters on the roof deck that grew tomatoes all summer and pumpkins all fall. And there is a long, long gravel road that makes you feel like you're coming home when you walk up onto the porch and walking into a beach cabin. Inside, the house is built around a small courtyard that lets lots of light in, and we designed a central core to house most of the utilities up and down from the basement to the rooftop deck. The little Ladino LED lights fill in the holes of the panels that were used for lifting the panels with the crane, and the 3-ply edges of the panels are left exposed to explain the story of how the house was made. We lightly whitewashed the wooden panels and had fun with some of the smart panels, turning them into CNC routed wooden screens that makes light patterns all over the floor in my daughter's bedroom. And with the thick R5 wooden CLT panels wrapped up with lots of thick mineral wool, our house is very quiet, with just the scent of light western white pine. With its high upward-reaching light vaults, it is very light-filled and natural. And every time we come home, we feel like we are going to our own beach cabin in the city. All the while, when we were designing and building our urban beach cabin in the city, we had another client, a modest, quiet group of folks that belonged to one of the oldest churches in America. These quiet people quietly asked us to build something that would help them transcend their daily lives and connect them to a sense of awe. These quiet folks thought about all the stories of CLT, and they thought about their desire to connect with a sense of awe and their desire to help take a stand on using ethical and sustainable materials. And they thought about all the risks that they would have to take to make the first CLT church in America. And so they proceeded. They bought a 1970s existing 43,000 square foot office building and asked us to make a large commercial mixed-use office assembly building for them. And so we began. We blew out the corner column the closest to the street, and we inserted a new 6,000 square foot sanctuary. Within the sanctuary, we inserted a folded plate of 40-foot high CLT walls as the backdrop to the sanctuary. The existing 44,000 square foot of office and TI spaces surrounding the big existing atrium were fully renovated and reused to become the church's new classrooms and educations. And then we ordered up 17 more panels from Structurlam. Sorry, Valerie, you guys weren't ready yet. From Structurlam, and worked with their CADWorks and operators to translate our Rhino models. We varied the 17 panels so that they would all be the same, but not quite the same, so that they would be ordered, but not perfectly ordered, so that when the light came and fell down upon them and through them and against them, they would be different everywhere and yet the same, sort of like all of us cantankerous human beings are with each other every day, still glowing in the same light around us. And then we worked with the engineers and the contractors and decided we would hang the 40-foot-high CLT panels off of steel trusses. The 17 panels were delivered to the site last November, and the 5-person team hung the panels from the steel structure in just over a week using old-fashioned ropes and pulleys and winches and lifts. We made sure that the natural light was far away and yet close enough so that you couldn't see the source of the light, and yet when you looked, light was everywhere, glowing and changing all over the great 40-foot-high CLT wall, so that the CLT would have the light coming down upon them and in between them, just like the light in the forest coming down between the trees. The CLT church opened up just 4 days ago, and there were many people who had tears streaming down their faces. Yes, because they had taken so many risks and worked so long and hard to build the church, but also because when they walked into the church, they could feel a sense of wonder and connectedness and, yes, a sense of awe. I'm also happy to say that the tears may have been flowing because we were only 0.6% within budget, or that's just $6,000, which is not bad for an $8 million project with an overall $25 million project cost. People were very happy. So as of Sunday, our small design firm, Atelier Jones, we have 6 people in our office, I believe has finished more built CLT projects in the US than maybe any other architect in the world, including my excellent colleagues, Michael Green and Thomas Robinson. And this is surely the last year I will be able to say this, so I need to say it now. But we are actively looking for the next opportunity to leverage our 2 US CLT projects. And in the meantime, our office is leveraging our own tested knowledge to be able to create a kit of parts for urban infill housing that will work for Seattle single-family infill lots, that will work for high-end multifamily projects or affordable housing projects. We plan to start a company to leverage this and are looking for the right partners. We will be moving into permitting stage for a prototype this summer and utilizing local private investment capital. But we are still thinking about all the trees that are growing up in Canada that replace the trees for our panels, sequestering carbon, and how all the wooden walls and ceilings and floors in the house and the church panels are sequestering carbon, and how all the trees that we replanted on my grandfather's land are sequestering carbon. We realized with my students in my office that we could count the panels and count the amount of wood and count the trees and count the acres that the trees needed to grow on. And we counted 17 trees that the panels were made from our house, and 17 trees that the panels were made from for the church. And we realized that 17 trees could have certainly grown on our Seattle house site and certainly more on our mixed-use Bellevue site. And we also think about all the carbon copies of our house and our church and the ancient site before the city and our CLT house and church with their carbon sequestering copies, and all the other carbon copies of the now managed forest of my grandfather, and this makes us very happy. We're inspired by this material. It can connect to so many diverse issues, from our deep carbon problems in the world, to our need to restore and manage our forests, to our need to help rural communities build a new and innovative job base, to ways to manage our forests to help forest fires, and to rethink about a massive reforestation program for this country. CLT represents a new lens through which to talk to one another again, in order to figure out ways to put forests first and people first, and to grow more forest, to make more small diameter timber, to make more CLT, to sequester more carbon, to get it out of our atmosphere, and to sequester us from the deep harm that climate change is fostering. For with all of these carbon copies, sequestering carbon, and with all of us talking to one another here and connecting to one another all over the world, from forests to carbon to timber to jobs to buildings to innovations to beauty and to awe, well, we are very hopeful that my grandfather's great-grandchildren and all the other great-grandchildren of the world might have a wonderful, wonderful future. Thank you for listening.